Now we're going to do the geometric series, right? So now we're going to focus on the geometric series, which has a standard formula of the sum formula, by the way, of Sn is equals to a into 1 minus r to the power of n divided by 1 minus r. This is mostly usable if r is less than 1, right? Anything else we can use Sn is equals to a into r to the power of n minus 1 divided by r minus 1, right? So here we're just gonna derive this sum here, right? And just to find out how is it formed. So let's start by deriving this. So since it's a geometric series, which means this sum is formed by the geometric sequence, right? If you remember clearly, the geometric sequence formula is T of n is equals to a multiplied by r to the power of n minus 1, right? So this formula here helps us to identify the geometric series formula, which is the sum, right? So if, let's say for example, so let me erase it. So now let's say we want to identify the sum of a geometric series. Sn is equals to term number 1 plus term number 2 plus term number 3 all the way up to T of n, right? Or you can say T of n minus 1 plus T of n, right? So this would be the last term, right? But what is term number 1? But T1 is equals to, so you're going to substitute in the formula of T of n is equals to AR to the power of n minus 1. So where there's n, you're going to put 1. So meaning that for T1, it's going to be A multiplied by R to the power of 1 minus 1, which is equals to A multiplied by R to the power of 0. So anything to the power of 0 is 1, so it's equals to A. So therefore, term number 1 is equals to A, right? And then term number 2 is going to be equals to A multiplied by R to the power of 2 minus 1, which is equals to A multiplied by R, right? And then term number 3 is going to be equals to A multiplied by R to the power of 3 minus 1, which is equals to A multiplied by R to the power of 2. So if you write that down in our sum, so S of n is equals to term number 1 is going to be equals to A. So it's going to be A plus term number 2, which is equals to AR. It's going to be A multiplied by R plus term number 3, which is equals to A multiplied by R to the power of 2, right? So it's going to continue up until T of n minus 1, right? So what is T of n minus 1? Let me use a different color. So T of n minus 1 is equals to A multiplied by R to the power of, so where there's n, you're going to substitute n minus 1, and then there's going to be that minus 1, so which means you're going to have A multiplied by R to the power of n minus 2. So that is T of n minus 1, right? So it's going to continue up until A multiplied by R to the power of n minus 2, and then plus the last one, which is T of n, right, which is just the formula of A multiplied by R to the power of n minus 1, right? So now we're just going to multiply by R. So we're going to multiply this sum here by R, by the ratio R, right? So we're going to say R multiplied by the sum of n is equals to, so each and every term that is here is going to be multiplied by R, right? So what we will have is this. So we're going to say, so if we multiply this A by R, we're going to have A multiplied by R plus, if you multiply this one here, we're just going to have, let me write this properly. So we're going to have A multiplied by R squared plus, if you multiply this one here, we're going to have A multiplied by R to the power of 3. It's just going to continue, right? And up to the last one where we have A multiplied by R to the power of n minus 1, right? So but because this is the last term, we still have to multiply it by r, right? So which is multiply, let me multiply by r here. So meaning if we were to say a multiplied by r to the power n minus 1 multiplied by r, we would have a multiplied by r to the power of n, like that, right? Because you would be having r to the power of so this is r to the power of n multiplied by r to the power of minus 1, right? Which is just for this expression here, and then you multiply by r, so meaning it's same base, it add exponent, so this is plus, this is minus, going to be 0, and you will remain with a multiplied by r to the power of n, right? So so you can see now that this expression here is actually going to be here, so we can just replace it and we say it's going to be equals to a multiplied by r to the power of n, right? Okay, so now let's continue. So now what we will do is this. Now we have two sums. We have the first one at the top. Let me indicate it as equation 1, and then we have this one which I'll indicate as equation 2, right? So what we will do is this. We're going to subtract the top to the bottom. So we're going to say s of n minus let me indicate with the color, minus r multiplied by s of n. So for this one here, we will have s of n minus r s of n is equals to. So if we subtract these terms, or these sums rather, it means now this ar will subtract this ar squared will subtract this ar squared, and then somewhere here is going to be ar to the power of 3, right? It's going to subtract this one here, and then even these ones will get subtracted, and we'll just remain with this one here and this one here. So we're just going to write that down. We'll remain with a, which I'm going to write a, and then this expression here, because it's going to subtract 0, because there's not going to be any expression like this one at the top, so you're just going to say 0 minus this expression here, so it's going to be minus a multiplied by r to the power of n, right? I hope I'm making sense. What I mean is, at Sn is going to be 0, right? And then at Rsn is going to be that a r to the power of n. So that's 0 minus a r to the power of n. Hence, you're going to get a negative a r to the power of n. So having this, we can factorize Sn into, so it's going to be 1 minus r, right? Close bracket equals to, here we can factorize a. So it's a into 1 minus r to the power of n, and then we're going to divide by 1 minus r, we're going to divide by 1 minus r, and then our sum is going to be a into 1 minus r to the power of n divided by 1 minus r, right? So this is going to be our sum of the geometric series, which, as I said before, you can also write it as Sn is equals to a into rn minus 1 over r minus 1. So this expression here, you can find it by multiplying this one by minus 1 over minus 1, right? Then you'll be able to get this expression here. Otherwise, this is the sum of a geometric series. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.